tells you what the pitch is. You got to convert that into trying to figure out how much weight that is.
That's right.
A little formula to do it. It's pretty simple once you figure it out, but that's how you know. And then we bought a scale and put the scale inside the machine, and it'll give you in grams, and then so you can put a weight. I mean, put your bolts on there, washers, till you get that amount. But that's if you put too much on there, and then you put it on the other side, when you run it the second time, the heavy spot will move from one side to the other. And that'll give you an idea of it. And on the lock homing, as many of us have, there's a bolt hole about every 30 degrees. And so when you put that bolt hole in there, when you put your heel in there, you might move it from here over to one side, but get it close to the edge, because that you didn't have it placed in between 30 degrees. If it's still out, you can always do it again, put another bolt on the other one, try to balance it, but you'll probably find it'll be down in that green area.
That's a great point. The 50 grams per inch that I talked about is only a starting point. One of the issues is the constant speed propeller is a lot heavier, so the weight of the prop relative to the motor is greater. It's going to take more weight. It may take 100 grams per inch on a constant speed. Once you know your airplane, once you know what that number is, then it'll be a lot faster the second time. 50 grams per inch, if you've got a real lightweight composite two-blade with a big motor, you might only need 25 grams per inch. So the 50 is a starting point, and then you got to take a lot of notes. You got to write down, okay, 50 grams per inch, went from this to this, and after a couple of runs, then you'll get your number for that aircraft. Exactly. So if you've got a small spinner, it requires more weight. The crush plate I have takes a lot of weight because it's right down inside of the propeller. If you're using a starter ring, it requires less weight. That's why the very high-end systems, you can spend $10,000 for a balancer, and we'll tell you exactly what weight to use. That's after 4 runs, because it's always an estimate going into it. And then after 4 runs, it'll tell you. What we've done is made it simple, and you have to write it down. You got to take notes, but you get to the same notes.
There's a little form in there that people just fill out what it was, and fill that out, and you run it the second time. That's another line for the second time or whatever. And that, when you look at that after doing it a couple times or 3 times, you'll really see, what effect it's having, what you've done had.
Right.
And Matthew, how about RPM? What do you use for RPM?
The RPM is generated off that photo tech.
How about normal running engine? Cruise RPM?
Cruise RPM, yeah. We always want to run at cruise RPM. And another good point, the photo tech is NIST traceable. So it's NIST RPM. A lot of tacks are off a couple of hundred. I've got a kit box, and if you turn the nav lights on, the RPM drops. So I don't understand this, but so it's good to have the instrument to verify your instrumentation. I'm sorry? Yeah. It shouldn't change it unless you've got a blade out of track or a blade out of pitch. So we usually, you don't have to run a lot of horsepower, you just have to run cruise RPM.
Yes, the definition goes per second.
It make a difference. Inch per second. Just inch per second. What it's telling you is that, why they did it is foreign to me. It moves 1 inch per second. That's the maximum velocity of the shape. And we could convert it to distance. Okay, well, let's move it up and down 5/1000ths of an inch. Or you could say, move it up and down 300 inches per second squared, which is acceleration. It's just always presented in IPS. Yes?
You said that you use cruise RPM.
Right.
On a fixed pitch prop, where you can only get a certain RPM static, would you just use maximum static?
That's what I do. I mean, if you have a fixed pitch prop and it's a cruise prop, you're not going to get cruise RPM, so you just want to go to best static RPM and balance it at that position. That's, you know, if you've got something like a RV or a long easy that's pretty fast in cruise, you're going to run into that problem. That's why some of the experimental guys will actually fly with it. So on the long easy, I actually fly with it mounted all the time because I want to be able to get 2,600 RPM and 2,700 RPM while I'm in cruise flight. Yes?
You mentioned that you only do it on the prop.
Right.
And the engine does affect it. And if it does affect it, will it knock your balance out then?
Yeah, that's a good point. The crank on a non-reduction engine is running at 1 per revolution. So that 1 per revolution balances everything that's at that rate. So for a standard, you know, non-reduction engine, you're actually balancing the crank, the prop extension, the starter ring, the propeller, the spinner. You're balancing the entire assembly. So if you ever take the spinner off and put it back on backwards, your balance is gone. If you ever pull the propeller off and put it back on, put it in the same spot, just safety wire will mess up the balance. So you're balancing the entire assembly. For a reduction engine, a gear reduction, in one of the GO engines, you're only balancing from the gear forward. The crank is at a different RPM and we disregard that. And all that information is thrown away. Things like pistons and rods that have a vibration, but it's not a rotation coupled to the crank, that's all thrown away.
It doesn't affect it?
Well, that affects engine vibration, but it doesn't affect the 1 per propeller vibration. So you can get into this issue where, well, let's say I want to balance the magneto, the mag, because it's at a 2-to-1 gear reduction. I've got to know that frequency. So it gets very complicated when you start chasing all the little pieces, all the other small vibrations compared to the propeller.
I'll make another comment. I think I've said this before. I had a Commander 114B that had air conditioning in it and had it balanced, and they put the weight on the flywheel of the Lycoming. It's critical that you make sure that the fan belt clears. I mean, and even though it looks like it, you know, you put it through the other way, but even though it looks like it clears, it doesn't necessarily clear because there's times when that belt may, at different RPMs or something, may move around. And, you know, after I had it done, I spent about $800 replacing belts and eventually bought a torque wrench, which now belongs to the chapter, because I was having to take the propeller off about every other day and replace the belt. But it would vibrate over, touch the bolt as it came around, flip the belt upside down, which would burn the belt up in a very short period of time. So just be very careful that you, when you put it in there, usually you don't have a problem with just one fan belt because the starter ring here on the there is pretty wide. But
That's a great point because we've actually had a customer start an engine where the bolt hit the starter. So you want to make sure after you put it in weights that you rotate the propeller through and verify that there's no interference. And this is a serious issue. We talk about the manual quite a bit. You know, you're going to be rotating the propeller. Make sure your mags are off, fuel's off. I mean, it can be a very serious issue if you've got the throttle engaged and you rotate the propeller and it kicks. There's no telling what you do with it.
tie the tail down.
Tie the tail down. But that is a good point about interference because that does happen quite a bit. There'll be a bolt head or, you know, 10 or 15 threads sticking out one side, which there shouldn't be, and then all of a sudden it starts engaging and starting. Any other questions? I apologize. I've kind of got a hard deadline at noon, so if there aren't any other questions, let's take a look at the installation that we've got. Maybe run it and take